So with our discussion of angles, we have 4 types of angles that are of particular note, that are particularly worth specifying. These are acute, right, obtuse, and straight angles, where what we're going to do is pull up a picture here so you can get a sense of what we're looking at, and we'll describe what each of them is. For our acute angles, what we are looking at are angles whose measure is less than 90 degrees. So these are things anything from 0 to 90, excluding 90. Meanwhile, for right angles, we are looking at those who have a measure of exactly 90 degrees and nothing else. Right angles are pretty specific in that way. Obtuse, then, are anything above 90 but below 180, so they're sort of wider looking angles. There it's marked on the clock by the, I believe that is, I guess you can't really tell if it's the minute or the second or the hour hand, but one hand on 12 and the other hand on 5. And then finally, we have our straight angles, which look more like lines. Those have a full, in a sense, measure of 180 degrees. So, with those constructions in mind, we can then develop another pair of definitions where we look at what are called complementary angles and supplementary angles, where we've talked a little bit about complements already, and this type of complement has a similar meaning to the things we've seen before. Here, for complementary angles, what we are looking at are pairs of angles whose measures add up to 90 degrees. So angles like 30 and 60 degrees. Those would be complementary angles. Or one small thing I should mention with these values, there's some special notations in terms of how the things are drawn that you can see with the right angles. If you zoom in a little bit, that there's a little box sort of drawn in the corner there to show that something is a right angle. Anyway, complementary angles are ones whose sum add up to 90 degrees, while supplementary angles are pairs whose sum is 180 degrees. So complements add up to form a right angle, supplements add up to form a straight angle. You can think of actually 2 right angles as being supplementary, which sort of makes sense if you picture that, like the 2 stuck together back to back. Or more generally, something like 140 and 40 degrees would be a pair of supplementary angles. And the way that we can use this is in terms of being able to recognize types of angles as, in particular, straight and, for that matter, right, and then seeing how other things intersect, how other things interact, and force them to change in a way. So, with these definitions in mind, let's think about one example like that. What we want to do here is, given that diagram, use the information we have, use the values given to identify the measure of the angle DBC. So first thing we should notice is when we're looking at that picture, we're trying to find out what our angle measure is our angle CBA, or ABC if you prefer, has measure 90. Because it has that little box drawn in there, but you can also sort of picture that if you ignore what's going on with dB there in the middle. And then also, we are given the measure of dBA, or ABD if you prefer. So, since the angles DBC and I'll say DBA, but you can change their names to whatever you want. In either case, they are complementary angles. We have that 90 degrees, the sum for the right angle CBA, is going to be equal to the measure of the angle, and I'll be a little bit briefer with my notation for angles here, but the measure of the angle DBC plus the measure of the angle DBA. That's how we notate that we're looking at a measure specifically. We just write the lowercase letter m in front of it. It's not the most detailed notation. That's nice. It's pretty clear and straightforward what we're looking at. Then what we can do is pay close attention to what we have given in those angles. The value that is actually given there is the measure of dBA. So, if we want to work with this, what we can do is leave that measure dBC alone for a while. But remember, this is a given value 62. So all we can do is subtract this over, and we will get that our desired angle, that is the measure of dBC, ends up being 28 degrees. I should be careful with that notation there as well.